All right, 2018, number 5. The following histograms summarize the teaching year for the teachers at two high schools, A and B. Teaching year is recorded as an integer, with first-year teachers recorded as 1, second as 2, and so on. Both sets of data have a mean of 8.2, with data recorded from 200 teachers at A and 221 teachers at B. On the histogram, each interval represents possible integer values from the left endpoint up to but not including the right endpoint. What that's meaning is that this range, let's choose a better color here. This range right there, that's all of the teachers between, that's all the 1, 2s, and 3s. This is all the 4, 5s, and 6s, 7s, 8s, and 9s, etc., etc. And that will be important. That will be important. For A, the median teaching year for one high school is 6. The median teaching year for the other high school is 7. Identify which school has which median and why. All right, so like my first thought was to look at the skew. High school B looks more skewed, and so that's going to pull the mean more. And since they have the same mean, that means it would have a smaller median. That does work, but it's honestly a lot easier, I think, just to count. So there's 200 here, and there's 221 here. So basically we're looking for 100 to 101 over here, and we're looking for 111 here. So where is that person? Which bucket do they fall in? Because thankfully, this being 7 right there, it means the 7 will be over here and the 6 will be over there, because the right one includes, like, it includes the endpoint on the left but not on the right. So this is less than 100. Because both of those are less than 50. This is like 113. We got 89 and 34, which is 113. So the median is going to be in here. It doesn't have to be 6. It could honestly be 4, but it is 6 because it tells us it's 6. So that's the way I would recommend doing it. You could certainly mark up those pictures. That would be reasonable justification. No, actually you can't, because you won't be able to print anything out. So, all right. Here's how I would write that up, then. Let's try that. School A. Has less than 100 teachers. In the first 2 bins. In the first 2 bins, 1 to 6 combined. And the median would be at between the 100th and 101st teacher. So the median of school A must be greater than 6. School B has 113 teachers teachers in the first two bins. Uh, 1 to 6 years. And the median will be the 111th teacher. Meaning the median at school B should be, will be between 4 and 6 inclusive. That was a lot of writing to justify a picture, but whatever. B, an additional 18 teachers were not included with the data recorded from the 200 teachers at high school A. The mean teaching year of those 18 teachers is 2.5. What is the mean teaching year for all 218 teachers at high school A? All right, so mean, add up all the values, divide by how many there are. But that also means if you take how many there are times the mean, you'll get the total. And that's what we're going to use here. So the current total number of teaching years is 8.2, the mean, times 200, the number of teachers. The total number of teaching years of the 18 not included is 2.5 times 18, not 1.8. Let's clarify that. And then altogether, there are 218 teachers. You type this into your calculator and you get 7.76. C, the standard deviation for the 221 teachers at high school B is 7.2. If one teacher is selected at random, what is the probability that the teaching year for the selected teacher will be within one standard deviation of the mean of 8.2? Justify your answer. All right, so this question, you start thinking, oh, normal model, I can do that. No, don't do that. Look at the histogram for high school B. That is not normally distributed. We cannot use any of our models for this. It is entirely possible that this question is unanswerable. But thankfully the numbers end up nicely lining up along bins. If that had not been 7.2 but had been 5.8 or something like that, this question is probably unanswerable. They chose 7.2 or made this data set to be 7.2 specifically to be able to ask this question. So the way we want to think about this, what teaching years are within one standard deviation of 8.2? If we go down one standard deviation, we have 1 year. If we go up one standard deviation, we have 15.4. All right, so one teaching year, that's going to be there, and that one is included, and that one should be included, yada, yada, yada. Here we have 15.4, so we don't want 16, we do want 15 because they're all recorded as integers. And so right here, that line right there, we'll have 16 over here, excluding, which we should, and we'll have 15 over here, including, which we should. So it's basically add all of those numbers up. We have, 89 and 34 and 28 and 29 and 19. So if you add all those numbers up, you get 189. Let's actually just write this down. Alright, so we have 89 plus 34 plus 28 plus 29 plus 19. And that was 189. And we're looking for a probability. So there's 189 teachers that are within one standard deviation out of 221 teachers total. So you do that, and you get 0.8552, an 85.5% chance.